I decided to record the video for the quiz review since I haven't been here, and I think the answers maybe won't be enough for everyone, so well, if you need it, watch it, otherwise, okay. So first problems I'm going to ask you to do are sketch the angle in standard position, and then find the reference angle. So, and then leaving in answers in degrees or radians depending on what it was given in. So first, to sketch it in standard form, that means that I want your initial side to be the positive x-axis, and then a positive angle we go counterclockwise, and a negative angle we go clockwise. So this would be negative 90, negative 180, so negative 140 would be right about there. And then the reference angle is always created with the x-axis and the terminal side. So I want the terminal side, the side that the angle ends at, and then the x-axis. Also, a reference angle is always an acute angle. So it's always going to be that 90 less than 90. So it's not going to go back to the positive x-axis. It's going to go back to, in this case, the negative x-axis. And then since you're completing the line here, the angle, the 140 and the reference make a straight line, and so you can take 180 minus 140 to find the reference angle of 40 degrees. A reference angle is also always positive, even if the original angle was negative. So my reference angle there is 40. The reference angles are not always the special right triangle angles. So a lot of times we find the trig values of our reference angles they work out nicely, but they don't have to be a 30, 60, or 45 degree reference. They can be different ones. In radians, 5 pi over 9, I'm going to sketch that first. So I'm going to think about in radians, it's positive, so I'm going to go around this way, pi over 2 pi. This is 1/2 pi, 3 pi over 2, and then back to 2 pi. So 5/9 as a decimal is like 0.5 repeating. So it's just over a half. So 5/9 would be, here's our initial side, and then it's going to be just bigger than a half. So that's 1/2 pi, so 5/9, just a little bit bigger than 1/2. So that's our angle. And so then this time our reference angle would be the terminal side along with the negative x-axis. It would be right here. And then I want to figure that out. Again, these two make a straight line, and this is 1 whole pi. So in radians, you could do 180 or pi minus 5 pi over 9 to figure out, take off what you have to figure out what's left there. So in order to subtract these, you will need a common denominator. Since I'm dealing with ninths, I'm going to make this 9/9 would be 1 pi. Then 9/9 minus 5/9 would be 4 pi over 9. So 4/9. And that would be my reference angle. I forgot the little reference angle would be 4 pi over 9. Now you could convert 5 pi over 9 into degrees by multiplying 5 pi over 9 by 180 degrees over pi. So times 180 over pi. So 180 divided by 9 is 20, and then pi is divided by pi is 1, and 5 times 20 is 100. So it's 100 degrees. That was the angle, and we drew it just over a half, which was 90 degrees, so that makes sense. And then my reference angle, this one, would be 80 degrees. But I asked you specifically to leave your answer in radians if it was given in radians. So I want the answer 4 pi over 9. So if you converted it and found the reference angle of 80 degrees, you need to convert it back to radians. Okay, find the exact value for the following. It will help to draw a picture. So cosine of 240. So cosine of 240, I'm going to draw a picture first. It's positive, so I'm going to be going around, starting at the positive x-axis, going counterclockwise. Remember, 270 is down here, so 240 is going to be down here. Then you're going to find the reference angle. The reference angle is always the angle that is with the x-axis and the terminal side, and it's the acute angle. So the reference angle for 240 would be right here. And since we're past 180, you can find the reference angle for 240 by taking the entire angle, 240, and then subtract off 180, and that'll leave you with this little piece right here. So 240 minus 180 would be 60 degrees. So I have a reference angle of 60. Then I'm going to make a right triangle here, and I'm going to label this triangle corresponding to this 60 degrees, which means this one would be 30. Across from 30, this would be 1 then. Across from the hypotenuse would be 2, and across from 60 would be the square root of 3. But since I'm in the third quadrant, my x-coordinate would be negative, my y-coordinate would be negative as well. And then I'm going to find the cosine of my reference angle, because the cosine of my original angle is going to be the same as my cosine of my reference angle, except for that it might be negative instead of positive. And so if I find cosine, that's adjacent over hypotenuse. So cosine is going to be negative 1 over 2. And that's your answer. So cosine of 60 degrees is positive 1/2, because 60 degrees is in the first quadrant. But 240 is in the third quadrant, which makes the cosine negative. But it will still have a value of 1/2. Okay, sine of 5 pi over 6. So 5 pi over 6. In radians, this is, remember, pi over 2, pi, 1/2 pi, and then 2 pi. So 5 pi over 6 is really close to a whole. 5/6 is really close to 1. It's 1 short. So you're going to start with your positive x-axis, and then 5 pi over 6 is going to be like right here, because this is 1. And if you think about it in terms of 6, this would be 6 pi's over 6. And so our reference angle would be the amount that we're missing right here, because those two angles would complete a straight line, and a straight line adds up to 180 degrees. And so if you want 5 pi over 6 plus 1 pi over 6 would give you 6 pi over 6, or give you the pi. Or you can take 6 pi over 6 minus 5 pi over 6 and get pi over 6. Now pi over 6 is the same thing as 30 degrees, because pi divided by 6 times 180 over pi, you end up taking 180 divided by 6, which is 30 degrees. So if this is 30 degrees, across from the 30 degree angle is 1. This would be your right angle, so your hypotenuse would be 2. This would be your 60 degree angle then, so that would be the square root of 3. This is the second quadrant, so the x-coordinate is negative, but the y-coordinate is positive, and then the radius is always positive. And then I want the sine, so I would do opposite over hypotenuse. So I would do the sine would be 1/2. And it would be positive, because the y-coordinate is positive in the second quadrant. You could also do these problems with the unit circle. These are just a couple ways to do it. So tangent of 3 pi over 2. So 3 pi over 2 is actually the negative y-axis. This is 3 pi over 2, that's 270 degrees. So I'm looking for the tangent of this. So that's called a quadrantal angle. So you're going to use your unit circle. You need to remember that there are the 4 main points on the quadrants, and our unit circle has a radius of 1. And so if this has a radius of 1, this point at 270 would be the point 0, -1. Then you'll need to remember that tangent is sine over cosine. So that means that tangent is the y-coordinate over the x-coordinate. So the tangent of 270 would be -1 over 0. So the tangent of 3 pi over 2 is actually undefined. Find all the angles of theta where theta is between 0 and 360 degrees and round your answer to the nearest tenth. If cosine of theta is equal to negative 0.5462. So first I need to use the inverse of cosine to find the angle. So this is cosine of the angle, gives me a measurement of side length. So this is, the adjacent over hypotenuse. So if I want the angle, I take the inverse of it and find the angle. Let's see if I have my calculator here. So make sure that you're in degree mode for this one. And then do second cosine and then negative 0.5462. So it gives me my angle of 123, and I wanted the nearest tenths place, so 123.1. And I want all of the possibilities, all of the angles. So if you think about cosine, cosine's the x-coordinate. This one, the x's are positive here. X's are negative in the second quadrant. X's are negative in the third quadrant. And then x's are positive over here, and y's are negative. Y's are negative. Cosine goes with, I wanted where cosine was negative. So I want, anytime the x value in my quadrant is negative, so cosine is negative here, and cosine is negative in here. So cosine is negative in quadrant 2 or quadrant 3. 123 degrees is that first angle right here, 123 degrees. If I want to figure out what angle in the third quadrant, so this is one answer, I need to find the reference angle first. So I'll need to find this angle right here, back with the x-axis. So since those two angles together would make a straight line, I'm going to take 180, take off 123.1 to figure out my reference angle, 56.9. So then in the third quadrant, this angle down here with the same reference angle, so with the same reference angle, this angle would have the same trig value, the same cosine value. So to find this angle, I would have to take 180 and then add 56.9 to find that angle in the third quadrant. So 180 plus 56.9 gives me another answer of 236.9. And then I limited this between 0 and 360 because you could continue to keep finding answers because anything coterminal. So if you went 123 plus 360, that would be another answer that has the same cosine value. Or if you did 236 plus 360, that would be another cosine value, or any of these negative values. So this negative angle or this negative angle, those would have the same cosine values. That's why I limited it to positives between 0 and 360. You can check your answer. If you did cosine of 236.9, you should get that decimal that we started with right here. This one. It's a little bit off because I rounded, but that's what I'm looking for there. Both of these answers and the quadrants where my answers fall. Okay, using the unit circle, solve for the following in radians. So let's look at the unit circle. If you have the first quadrant memorized, you should be good to go. So the unit circle is a radius of 1. So we have the point 1, 0 at 0 and 2 pi degrees. We have the point 0, 1 at pi over 2 degrees. We have the point negative 1, 0 at pi degrees, radians, and then we have 0, negative 1 at 1/2 pi radians, or 3 pi over 2 radians. And then we have the three main ones. So radius of 1, we got 30 degrees, And what's this ordered pair right here? We had said, okay, the radius is 1. I want the x and y value. Well, the x and y value around the circle correspond to the, remember, x, y correspond to cosine and sine. So you can find these values a couple different ways. You can say, all right, this is a 30, 60, 90 triangle. My radius is 1. This is my 2x, which means that my x would be 1/2, and then I would divide by the square root of 3, so this would be the square root of 3 over 2. That's one way to get those values. So then x is the square root of 3 over 2, and y is 1/2, using the x, 2x, and x square roots of 3 relationship. I think that's a little bit confusing, so I usually just look at, okay, if I want to derive this for 30 degrees, I go back to my 30, 60, 90 triangle, and I just draw that. And I look at my 30 degree side as 1, my 60 degrees square roots of 3, and my hypotenuse is 2. And then I remember that my x coordinates are cosine and my y coordinates are sine. So then the cosine of 30 degrees is adjacent over hypotenuse. So square root of 3 over 2, cosine. And then the sine of 30 degrees is opposite over adjacent, or 1/2. And then I do the same thing for 60 degrees, or for 45. I'll do 60 next though. And do the 60 degree one. Since I have that drawn, I need to move that pi over 2 over here so I have some room. So the third mark is 60 degrees, so finding the cosine of 60, this time I would do adjacent over hypotenuse, so it's 1/2. And then the sine of 60 would be a opposite over hypotenuse, so square root of 3 over 2. And there should be a connection between these two, because these ones are co-functions of each other. So the cosine of 30 should equal the sine of 60. The sine of 30 should equal the cosine of 60. They're co-functions. And then the angle that splits it is the 45 degree angle. So we need the 45, 45, 90 triangle. A 45 is 1, 1 square roots of 2. Sine and cosine are both 1 divided by the square root of 2, which rationalized equals the square root of 2 over 2. So for 45 degrees, this is the square root of 2 over 2. Square root of 2 over 2. All right, so why is that helpful? Well, I can look at this and say, okay, what angle does sine equal the square root of 2 over 2? Well, sine is my y coordinate. Sine is equal to the square root of 2 over 2 at 45 degrees. 45 degrees is pi over 4. So I do need to know them in radians. Pi over 4. Basically, 180 divided by 6 is 30 degrees. 180 divided by 3 is 60 degrees. And 180 divided by 4 is 45 degrees. If you know those three, you can figure out any of the radians, because pi over 6 is 30, pi over 3 is 60, pi over 4 is 45. So pi over 4 is one answer, because sine is positive in the first quadrant. Positive. Sine is also positive. Remember, sine is my y coordinates. So sine is also positive over here, because it'd be negative cosine but positive sine, because it's negative x, positive y. So wherever I had a 45 degree angle, reference angle over here. And in radians, think about that would be my 45, so pi over 4. So I would take my pi, and I need to go back. The whole thing would be 180 degrees. I need to go back pi over 4. So I'm going to subtract pi over 4. And having a common denominator then, so 4 pi over 4 minus pi over 4 is going to be 3 pi over 4. That's my other one. So it was quadrant 1 and quadrant 2 where sine gave me a positive value. And it was for 45 degrees. So in degrees, this is 45 degrees. And then this one would be 135 degrees. 180 minus 45. So you could do it in degrees and then go backwards. But that's how you could find those values. And then for tangent, since tangent's not part of my unit circle, I would probably use just a special right triangle to figure out where tangent is square root of 3 over 3. If you see a square root of 3, hopefully you think that comes from the 30, 60, 90 triangle right away. So 30 is 1, 60 is square roots of 3, and 2. So if it's got a square root of 3 in it, that would be the 30, 60, 90. Tangent is opposite over adjacent. So it's going to be 30 degrees because that's going to give me 1 over the square root of 3, which actually simplifies to the square root of 3 over 3. So the tangent of pi over 6 is square root of 3 over 3, but we're negative. So tangent of pi over 6, or 30 degrees, is the square root of 3 over 3, but that's the first quadrant, so tangent's positive there. Tangent is sine over cosine, so it will be negative anywhere sine and cosine, x and y different in signs. So all of them are positive here. Sine's positive, cosine's positive, or tangent's positive, cosine's positive. So tangent is negative, which we have a negative value here in quadrants 2 and 4, because in quadrant 2, x is negative, but y is positive. And in quadrant 4, x is positive, but y is negative. So tangent's negative there. Okay, so where does that leave us? We have a 30-degree reference angle in this quadrant, which would be 150 degrees. So tangent of 150, but I want that in radians. And so it would be pi, take away pi over 6. So take that 180, that full amount, and then take off a reference angle of pi over 6. So if you take 180, take away 30, you get 150. If you do it in radians, you do pi minus pi over 6. So that's 6 pi over 6 minus pi over 6 is going to be 5 pi over 6. Then we need to do the same thing, but we need to be in quadrant 4. So it's a little bit different because we have a full circle is 360, and then I know I have a reference angle here of pi over 6. So to find this angle this time, we're going to have to take the full circle and then take off pi over 6. So you could do 360, take away the 30-degree reference, and you're going to be at 330. So if that makes sense in degrees, do it and then convert it back. In radians, a full circle is 2 pi. Take away 30 degrees, pi over 6. Common denominator then would be 2 pi is the same thing as, you'd have to multiply both these by 6. So 12 pi over 6 minus pi over 6 would be 11 pi over 6. And those two angles then would have the trig tangent value of negative square root of 3 over 3, because tangent of 30 is the square root of 3 over 3. Okay, remember that there's more videos on this from Miss Brenda Mule if you want to go back and watch any of those, but I hope that was helpful.